Hello everybody, and welcome back to the Inicus project. So today we're going to be working on the Millennium Falcon some more, and maybe for the last time, at least for a while. We worked last time to port over to this new control board we got, which is here, and it's running the lights right now as you can see. And we did a lot of work to make sure that everything worked fine there. We did some testing and found that it worked much better. The lights can actually run a lot faster now than they used to, which is awesome. So we're making great progress. The last little thing we had to do that we're going to do tonight is add this memory card. The board has a spot for the memory card on it, but we're not using it at the moment, but that is the reason I bought this particular controller. This memory card will allow us to run the lights on the Falcon without having it plugged into the computer. As you can see right now, this cable right here is running into my machine, into my PC, and that's what's controlling the lights. All the commands, every time the lights change, it's because a command was sent over the cable to the controller. It's cool for testing and everything, but it's not ideal in the real world because when you set this thing up on a shelf or something, you're not going to want to have to plug it into a PC and run some program on the computer to run the lights on the Falcon every time. So that's what this is for. We're going to make a method for running the program and saving it to the SD card, and then later if you plug the device in without connecting this cable right here, it sees that, understands what's going on, and runs the file from the SD card instead. So, seems pretty neat. I think it's pretty straightforward. There will be a little bit of wiring afterward as well because we'll have to power the TNC off the 5 volts, which is not going to be. Let's see, what's the best way to do that? I'm just thinking out loud. We'll power it off this thing right here. Should be fine. There should be a pin on there that allows us to do that, like a 5-volt input pin. Yeah, seems pretty straightforward. All right, so let's get started then. First things first, I guess we gotta. So in a previous stream, we had taken the time to test out the SD card with this board by just writing a dedicated program that just created a test file on the SD card and read from it to prove that it could. And that worked great. So I have that pulled up, and I'm going to use it here as a reference, and we're going to modify our existing code base for the TNC. So let me pull this up here. All right, so this is our existing code base. You know, we have all these files that are running the different parts of this lighting kit. And then I have the other one. All right, cool. And it seems pretty straightforward. It doesn't seem like it should be too hard to add this, but I say that now. All right, and I think there's something else that I feel like I'm missing here before I jump into this. Oh yeah, we got to change our goal here. So instead of build the new circuit, we've already done that. Add SD, or how about memory card? Commands to, oh, what do we call this? Lighting kit, I guess. Hopefully I can make this fit. Just a little bit off there. That's okay. There we go. All right. That's a good start, and let's get going. All right, I'm going to go through this again because we got to figure out exactly what's going on to make this work. This is character, process command. All right, command invalid. Okay, so here's what I'm thinking. And the easiest way I can think of to make this work, we send a command at the beginning that says start recording, basically. And then when the teensy gets that command, it knows, okay, open up the SD card, open up the file, brand new file, and then every command that comes after, I'm going to not only process and run, but also put in that SD card. Then go through and then I guess we would need one at the end as well for stop recording that lets it know, okay, close that file, we're done. I think that makes sense. And then next time, and then we also need to check on startup for this cable, and if we don't see it, then we need to run the file or run the commands that are on the SD card. All right, there's going to be a few different logic things going on here. See, receive data. All right, let's just go ahead and declare that, and then we're actually going to put a loop down here. There's a few different things we got to do. Hopefully I'll keep it all straight. All right, so if serial actually, no. You know what? We're going to run this. We're going to create a variable up here for this. Running from serial. And we'll start that off at false. Okay. And then we need to come up with a time. Is elapsed milliseconds a thing in here? How do you spell it? Elapsed. I gotta Google this one. It might be a library that has to be added. There's a thing in that I've used before called elapsed milliseconds, basically. And here it is. You basically, like, by storing the value. Huh, it looks like this teensy specific thing. That's kind of interesting. Okay. Or at least it was designed by or created by the guy that made the teensy. Yep, it is. Okay. Interesting. Elapsed millis. All right. Layer can respond to user input while the delay is happening. This is as time elapses. Cool. I just got to see an example of it real quick. To remember exactly how it works. So what this will allow us to do is track the time that has passed, and basically on this loop right here, while we're checking for the serial port, we'll wait like 2 seconds, and if we don't see the, or I guess 5 seconds, and if we don't see that serial port open within 5 seconds, then we continue on and assume that that there's no serial port connected, and we're just going to run from the SD card. All right. And I'm just looking for a quick example real quick. Okay, this seems pretty straightforward. The name is serial start time. And then I believe we just set this equal to 0 and then check until it's greater than 5,000. So we're also going to need to define. Where did I put those above that? Time to serial. It's going pretty good. Just trying to figure out how exactly I'm going to add this memory card. How's your Thursday going? Okay, time to serial. All right, so now down here. Actually, you know what? We probably don't even need to put this outside. Equals 0. And then while not serial and start time is less than time to serial. I hear you. It was a busy day for me too. But I'm glad to be working on this now. Okay, and then we need a way to see if the serial port works, like what the result was. No, you know what? This needs to go somewhere inside. We need to put this in the loop here and break out of this loop if we reach this point. Okay, so if, whoops, not that. I want this. Oh, everything's going wrong. All right. All right, so if the serial start time is greater than time to serial, so basically this object, the serial start time, is going to increase by 1 every millisecond, so 1,000 times every second. And then if it reaches above this value, or above or equal to time to serial, which we defined up here as 5,000, or 5 seconds, 5,000 milliseconds or 5 seconds, then we'll go in here and we will set our variable running from serial. Ooh, you know what? Might have had this backwards. Let's say true. And then let's say running from serial equals false. And then break. And then break will break out of this while loop right here. Okay, so what this will do is try and open the serial port and wait for it to start. And if it does, then we'll skip over this. Obviously, we won't ever hit this point. We'll just break out and we'll know that we're running from serial. If it doesn't reach that, if we do reach this timeout, then we'll set running from serial equal to false and break out, and we can use this variable to check and know that, and we'll start running from the SD card. Seems pretty straightforward. All right, so down here, if running from serial, we'll need to give the response. I keep doing Python. Check for the timeout. Then send response if necessary. Okay. And then we initialize our buffers, which we're going to have to do anyway, whether or not we're running from the SD card. Okay. And then down here, if running from serial and then we're going to do this. We're going to say receive data serial.read. All right, straightforward. And then up here, we'll just take this out. Else, receive data is going to have to be the next item in the file. All right, and then I guess we'll have to check for. I don't know how exactly this file reader, like it's only got one command for reading, which is just read. I don't know what it returns if you reach the end of a file. I assume it's null or something, but I should probably look this up and see. Oh, okay. There's a way you can check this. Okay, so we're going to have to create some objects here. But we can check this and return the appropriate values as necessary. It's an integer, right? So we can return the integer. Okay. So we'll probably have to create our own kind of our own library or functions for it. It's not that complicated of a library, so I don't even want to create its own files or anything. I don't think we need any of this, so I'm going to get rid of it all. Yeah, I think we just create some functions in here for this. Okay, so let's just create some global variables as well. And let's go ahead and add in the things that we need here. So we need SPI and then Yep. Okay. Tools. Let's go to our library, or sorry, sketch, include library. And then we need SPI. And I still don't know why these are so far down here. I'm going to put them up here. All right, there we go. And then we also need to include SD, right? No. That's weird, it included a couple things. It's a different library. This is what it is. Okay. This is the library for the storage protocol. All right, so from there we should be able to create our global variables, file, my file, and then we also need to set up our SD object. Okay, then I think I'm going to try and compile this real quick just to prove that there's no issues bringing those libraries in. There probably will be, though. There's quite a bit of code here, so it might take a bit to compile. Waiting, waiting, waiting. There we go. A few warnings. Used uninitialized, used uninitialized, used uninitialized. Those are all fine. They were intended to be that way. Okay. So it looks like this all is looking good. And then I gotta find out if there's anything I missed here. There's a few defines I think I have to do. Yep. And constants as well. All right, this is setting it to the exFAT, which is the file storage system that's used on this SD card. There's FAT16 and FAT32, which are fairly common in older stuff. This is a 128 gig SD card, which is much bigger, and so requires a newer system, so it uses exFAT. And then we need our chip select as well. And the SS line is defined constant for the select line for the SD card. Okay. So that's good there. And then we need a function for opening the SD card. And that doesn't take any arguments. By the way, if you have any questions or suggestions on how exactly I should be doing this, feel free to let me know. I'm all ears. Okay. So now we just got to open it. Oh, hold on. Where do we mount it? There it is. All right, if not sd.begin, and we're going to use our some of the functions that they've set up here. I think this chip select function, where is this used? Huh, nowhere. It may just look for it externally. Okay. I'm just looking for where that chip select variable could have been used at. All right, there's some other functions we got to call that are specific to this library. All right. So attempt to open the SD card. All right, so that's what this function does, is try and start communication to the SD card. There's a protocol that happens, a handshake that happens, that lets us know that it's good. And these are just some optional function with a parameter to set everything up correctly. Okay, and then what to do if it fails. I wonder if Teensy has a reset. That's got to be a thing, right? Most chips have them. Because if it fails, there's not really anything we can do. I might have to find it exactly. I guess if it fails, we just wait here for now. All right, if it does work, then we want to open the file that we have saved on there. And I guess we got to come up with the file name. SD file name. What should we call it? I guess playback.txt. That seems to work. All right. So now we need to open the file, and then, yeah, my file equals sd.open. I'm pretty much just copying a lot from what I had last time when I did the test. And then we want this in read mode. There we go. Excellent. All right, we're gonna, man, I'm just thinking through this, like opening and closing files and reading things and all that. There's gonna be a lot of places where this could error out if the wrong data is sent over the cable. And I'm not sure like how much of that I should handle and how much I should just expect not to do it. Ideally, I would handle all bad cases, but I don't really think it's worth the time right now. All right. And so we open it, and if not my file, then we hold here. All right, so open the SD card, open the file. If either of those fails, we just wait until we basically power off and power back on. And then for here, we'll say this sets up the SD card for reading. All right, cool. So now up here, oh, I guess we gotta declare our function as well. All right, and then we'll call this right here. All right, that should be good. All right, and then it looks like if you're debugging, we respond with that. We're not going to be debugging in this. All right, so the next thing we need to do. Oh, shoot, you know what? I called this in the wrong place. We need to do this here. Because on setup, if it looks like... All right, open the SD card. All right. Looks good. All right, then here we need to get the next data from the file on the SD card. And the way we're going to do that, we have to make another function. cdata equals get character, or I don't know, read file or something. And then we'll need to make this down here. So all this function is going to do is return an integer, which will be the character read from the file. Or, if one's not available, I guess we'll return -1. And that's how we'll signal that we're at the end of the file. Okay. There's a way to check if there's something still available. Here it is. If my file dot available and return my file dot read. This will read one character. And I am slowly getting stuck into Python again and forgetting my brackets and everything. Else, return -1. SD card returns -1 if not available. If it returns -1, what we're going to want to do is close the file, reopen it, and start again from the beginning. Maybe we should just do that here, actually, in the else. That probably makes more sense, honestly. My file close. .open. And then we need the name. And the mode. Read. And then we probably need a case here where, like, if we just opened it and nothing's available, that means it's empty. We probably just need to hold. So if not, my file available. And we probably need to do this down there in the function where we start everything up as well. While true. Let me add some comments here. Check for empty file. Man, there's gonna be a lot to debug after all this. Excuse me. If we don't get stuck, then we know we're good, and we'll return same thing as before. My file dot read. Character. Okay. This function could have been written a little more efficiently, but that's okay. That's fine for now. Down here, we need to do the same thing that we just did here. This check. This way, if we do get an empty file, we just hold in place. All right, that looks good. And then finally, we need to declare this. And then let's just make sure everything compiles. There we go, already got an error. Control reaches the end of a non-void function. Ah, yeah. If, else. All right, that's just a warning. It shouldn't reach the end of a non-void function. But I do think I've missed a parentheses somewhere. Right here. It's definitely going to land in one of these, which will return, but I guess it doesn't realize that. So what I'm going to do is just simplify this statement. If not available, then reopen the file. And then this moves over. Okay. So we're always going to read from the character down here. This just checks real quick to make sure that we are where we want to be. And then I'm going to need to put that bracket there. And it looks like I'm going to need one more closing bracket. There we go. Excellent. Reaches the end of a non-void function. Where is that? 179. This can just be void, because if something fails, it's just going to hold anyway. So there's no reason to have that return a Boolean. We're not even using it when we call the function. Excellent. Okay. Looking good there. I think... Man, we've used practically 0%. We've used almost nothing of the storage space with this program. All right, this looks good. So it just consistently gets the next character regardless of where it's from. And then the only thing we need to check is here. From now on, our serial commands need to, before we say, you know, write to the console or write to the serial port, we need to check if we actually are using it. So if running from serial. So that's the only downside, is we have to go through now and find all these places. If running from serial, then write command invalid. And I'm just going to copy this so I can add it in places. There we go. And there. Awesome. And then reset the buffer and do everything again. That looks good. I don't think here in the parser we write anything to the serial port. Nope, doesn't look like it. Okay, cool. So now the only thing we have to do is add a command for if we are currently creating the file on the SD card. Because that's the easiest way I can think of to create these files, rather than making them by hand, is just record it as it's coming in through the serial port. Seems to make the most sense. The question is the best way to do that. I'm wondering if I should just record everything that comes through anyway. Like if we're running it from the serial port, just always record that data, and then every time, then later when we unplug, it just runs the playback of whatever happened before. Or do we make the program specify? See, what I don't know is when we write to the SD card, if that write gets reflected, if the file is actually written to the SD card until we call the close function. I actually do not know on that one. See, Arduino file. Close. And ensure any data. Okay, so I think we do have to call the close function in order to save the data to the SD card. There's the risk that that data won't be saved if you don't call close. So we can't just assume that as we're going, it's writing it to the SD card, and then every time you unplug it. Although we could do that. Actually, we could just open and close every received character, but I feel like that would take a really long time. That doesn't seem like a great idea. Yeah, I think we need commands. There's no way around it, unfortunately. Okay, let's see here. Parse command. I think we can take this. And write it to the... So we could put it in here. Basically, if recording, write this data to the SD card. That would make sense. There's a couple things we probably need to set up, though. We probably need some globals here as well. Receive data. Command buffer. Alright, I'm just trying to think through how all this worked again. Let's see. If I do this a certain way, I can basically avoid modifying the Python script, and I'm trying to decide if it's worth doing it that way. I don't know, though. Oh, we're gonna have to pass a variable in and everything. Yeah, let's just do this the way originally intended. Python comments. See, now I'm second guessing myself because I'm going to have to open up the files in here as well. I kind of don't want to do that. I'm going to have to bring these libraries in and create different file objects and everything, and I'm worried about things getting kind of mixed up. And I'm just trying to avoid that. Like if we were to not open the file, or open the file here and then tell it to record and then try and open it there, and it just becomes a mess. Things start throwing errors in random places and failing. What if, let me see what how this works exactly. SD open. Okay, and what is that argument type there? It's mode. I don't know what these defined values are. It doesn't tell me what data type this is, which would be kind of important because that means I can define that ahead of time, but I guess not. Okay. I'll make this a Boolean. If reading then we open the file for reading. Pretty straightforward. Else we open it for writing. Evidently, according to this document, these are the only two modes available. Which I was talking about before, how there's other modes, which is like read and write and append and all that. Like, these aren't the only two modes available on most file systems. Odd that it's the only two supported here. That's okay. It's all we need, but... Alright. And then up here, when we call open SD card, that's true for reading. Otherwise, false for writing. And then, if that's the case, every single command that we receive, we want to go through and see buffer in it, reset the command buffer. Every single command we receive, we want to go ahead and write it to the file and probably close and open it again. So maybe a function for writing command to file. Command to the file. This is going to get really complicated in the logic, and I can see this going really wrong in a few different places. Here's to hoping that doesn't happen. Alright, so void write command to file, and then I assume we're going to get a character buffer. New command. And then our file write, I don't know. Bytes, the number of elements to write. Okay, so we can pass it a string. Okay, good to know. Dot write. Let's just do new command. However, there's something else I want to cover here. If we're delaying in commands, there's going to be a time delay, and when we play back the file from the SD card, we're not going to know that time delay. So I want to include a delay here that I write to the file. And we need to make a time delay command, basically. So we can create a character buffer here that's, I don't know, as big as the, not that big, but big enough that we can easily what am I going to say? Easily fit in the command for delaying. There is a delay command available, and so we'll make use of that here. And then I think in here we probably define command buffer length. Yep, so that's the max right there. That's fine. That will work. And then we need to memset this to 0. Man, I can't believe we're almost done with this project. It's going to be wild. I've been working on this thing for like 2 months now, getting it all set up, and we're pretty soon going to go to something completely different. Well, not completely different, but it's not a Millennium Falcon. Okay, and then somewhere in here we had that elapsed millis. Is that within a function? It is. So we need a global variable up here for it. I wonder what the max on this is, if we could ever possibly overrun it. I don't think so. Not reasonably, but that could happen one day, I guess. Okay. And then we probably need to define a constant for this. What was the delay command? It'll be down here somewhere. Set1, set mini, delay. And then I think it's only one parameter, which is milliseconds. So where do we define this at? Probably just up here. Command. Delay, and then that'll have the time. And then yeah. All right. C concatenate strings. You can use the string cat function, which depends the string pointed to the source to the end of the string pointed to by destination. Okay, I think this works. I apologize if this is super boring as well. It's not the most exciting thing in the world, but it's all part of the job. Alright, so string copy, delay command, and this. Alright, so that's going to create it, and then string cat. And then we need to take our, shoot. I guess just elapsed millis. What is it? What do we name that up here? Does anybody remember? Write delay. And then we need to convert that. Okay, here it is. Integer to string. Write delay. Oh, it needs some sort of temporary buffer to do that. Number. This will be a custom. 16 is enough. Command. Create buffers. I don't know if anybody caught it, but I missed a semicolon here. Okay, and then how does this used? Numbers first, and then the buffer. Which is number. And then the base, I believe. Yep. In our case, we want to do base 10. Do we want to do base 10? Or do we require hex? That's actually a really good question. And return 16. We were doing hex, okay. Never mind. And then finally, I think I missed a parentheses here. We need the end of the command, which is just going to be a closing bracket and then a new line. All right, cool. And then we should be able to write that here and see it. So we write that, then our new command. Oh, if we close it and open it, though, we're going to be... We'll be back at the beginning of the file again. Oh, man. This isn't going to work. That's really disappointing. Really disappointing. See, this is where we would like to have a new, or have have more options. We need an append mode, but it doesn't look like that's available here, which is really kind of sad, actually. Let's see. Hold on. There might be some more stuff that I don't understand here. I wonder if is there a flush? It's done automatically when the file's closed. Okay. We don't have to close it. We can literally just call flush. That's what I needed. Perfect. So when you write to an SD card, there's a space there, a buffer, that things are held in temporarily while it's figuring out where to write stuff and all that. And calling flush waits for it to physically write everything to the SD card to those files, and then you know your data is for sure stored. Makes sense. All right, cool. So now we don't have to worry about anything. We can just keep going, and it'll flush to the SD card every time. Assuming all of this works, of course. It might not. All right, so now I guess we just got to put the logic in for when we write to the file. Here we go. For parse command, and then let's see, not there. All right, so else process command right here. And then we want to find the exact thing that we were. If running from serial. Oh, shoot. I think I messed this up. Write command to file. That's what we want. And we want that right here. And then we want to, so we want to do current command. And then this is a specific parameter. Command buffer. That works, right? It's character command. Yep. Supposedly that's correct. I see a lot of places where this could go wrong, and it's going to be very hard to tell. So let's go down here to this and just print this stuff out. Print delay command, and then serial.print new command. And this way we can actually, assuming that all this gets started correctly, we can actually see it writing to the SD card. And then I guess I'll just do a couple test commands just to make sure, rather than run it from the Python script. Okay. I'm just trying to think through, is there anything else I missed? Oh, you know what? This write delay. We need to set it equal to 0. It needs to reset after every single one of these. That'll keep it from getting out of hand and overflowing as well. Okay, serial print. I think this works. Let's compile and find all our bugs. There's got to be, I'm sure, some missing things. Command buffer was not declared in this scope. Where's that at? Oh, we got all kinds of stuff. Well, it can never be easy. 145. Command buffer. Command buffer length. Invalid conversion from character pointer to uint 8t. Really? Line 156. It's annoying that it doesn't just take me there. Delay command. How is that an unsigned int? I say up here that it's not. This is what I'm confused about right here. This statement. Whoops. Arduino, everybody. Sorry, the scroll bar is behind my phone too, which makes it a little hard to see. Invalid conversion from character pointer to unsigned int. Where is that conversion happening? Is write... Okay, hold on. Does the write function need to be past an integer? I could see that being a thing. Maybe it's the print function is what I'm actually looking for. Double checking. Hold on. Write is supposed to be able to use a character pointer. Odd. Maybe in this weird library I'm using, though, it's not. What's print? Long or string? Oh, let's just try print instead. That's probably fine. All right, let's redo this. See if we get these same pop-ups. No errors that time. I'm worried that some of our warnings that we had before. Is there like a clean? So that okay. Oftentimes when you recompile on the same thing, it won't show you some of the previous warnings. It'll only show you errors. And I don't like that. I'd rather it show me those warnings every time. So sometimes there's a some sort of like clean or reset or rebuild thing that you can use that just starts from scratch and rebuilds the entire thing. But I guess not. All right, let's upload it. What could possibly go wrong? Unable to open Com5. It's probably because we're running it off the Python script still. That would do it. All right, excellent. Let's try again. Okay, it didn't print the ready command. That's kind of concerning. Let's unplug it and plug it back in. Nothing. All right, so we haven't gotten there yet. Why isn't it printing ready? I must have gotten some logic bad over here. It should be writing this. Open SD card, false. So for writing, maybe it's getting stuck here. Oh, it is. And you know why? Greatest mistake ever. I still haven't put the memory card in it. So it's trying to set up the memory card and it's not even plugged in. Let's just try that again. Oops. And nothing. Cool. I wonder where it's getting stuck at. All right, well, I guess we're going to need some debug statements then. So it goes. All right, just to make sure we're getting here. Print. We'll have to take these statements out later, so it's fine. This is what happens when you don't have a debugger. You gotta go ahead and put all these print statements in. Three, 4. All right. Excuse me. Six. All right. Looking good. And then let's upload this. I'll go ahead and open our monitor here. 1, 2, 3, 5. Okay. So it mounted the SD card just fine. It's not opening the file correctly. Why is that? Hold on. If I look here, 1, 2, 3 tries to open the file in read mode, but we're trying to write to it. The file doesn't exist because we're trying to write to it, so it's getting stuck. Okay, that makes sense. The question is why? If reading is true, then that's what happens. So we need to go to where this call happens, open SD card. If running from serial, open SD card, false. Otherwise true. So this isn't setting equal to true. Running from serial equals true. If start time is greater than time to serial, running from serial is false. This is interesting. My logic is not, something in my logic is not quite working here. Zero. All right, well, we're just going to do this around a few times. Compile and upload, compile and upload. All right. 1, 2, 3, 5. Yep. So running from serial is false for some reason. If start time is less than, gosh dang it. All right. That is my mistake. That comparison is backwards. My bad. It's the easy stuff that'll get you. All right. I think that worked. 1, 2, 4, 5, 6. So we went here, and then went down here. 5, 6. Check for empty file. Oh, shoot. This doesn't work if we're reading. So if not my file and reading, then that's where we should hold that. Same for, well, up here we only call in read mode anyway, so that's fine. All right, so verify that. Awesome. I'm glad you find it funny, Beth, because I get myself with those little errors all the time. All right, ready. Excellent. Progress was made. Init 19. No, this is a hex value, and I can't remember what 21 is in hex. 15, I think, translates to 21 in hex, and then we want to start off with, I don't know, red. Received, and then update. Everything goes red. Looks good. Looks like our delay looks good. Delay, update, init. Okay, I think this is working. And then it should play it back. Simple things are harder for smart people. I agree. If you really know what you're doing and you think you're an expert, you gloss over the simple things, and so they're the ones that bite you. I was reading something really interesting the other day that was only great people make big mistakes because nobody trusts people who aren't considered, I guess, intelligent with big decisions. So they don't have an opportunity to make big mistakes. So that's why only the supposed smart people make the big errors, because they're the ones trusted with making the decision. With great power comes great responsibility. All right. I think this is good. Let me just unplug this. Actually, yeah. Let me just unplug this and see if our whole system here worked. I'm going to plug this SD card into my computer and check the file and see if it looks good, if it recorded everything like it was supposed to. Check it out. There it is. Everything's in there, just as we want. All right, cool. I can run an office, but I can't balance a checkbook. Yep. All right, let me get rid of one unnecessary file and then eject this again. Oh man, I'm glad we're getting close. I don't know how this is going to work though. So now here what I'm going to do is I'm going to plug this back in and I'm going to turn the TNT on. And I'm not going to turn on the serial port. Keep that closed. And it should turn the LEDs red again. But turn them off with a delay and then turn them red. It's going to wait 5 seconds. I don't actually know if this is going to work or not. All right, looks like it's not going to work. It can't be that easy. Two, three, four, five, six. 1, 2, 3, 5, 6. So where did that end up? Opened in read mode. 5, 6, and then it's hard to tell. It may have just we should probably do more than just this one command. Let's just start over. All right. Init 1.5. I don't know. 1.9 actually. Let's make it longer. Let's do red. Let's do bright red so we can just see this happen. Update. Yep, super bright red. And then we'll do bright blue. Set many 0, 1.9. I think that's the command. Command invalid. Whoops. I forgot how that one worked again. Set many neopixels. Date pixels, get length, and it's a function down here. Update neopixels, set one neopixel, set many neopixels. So index, color, and then number. Okay, I got that backwards. Set many index, color, and then number 1.9. Command received, and then update. Wow, that was a long delay between them. I should probably do that again. Let's see. Update, copy that. And then copy that. All right. We're going to start over. Because I don't want there to be a super long delay. All right. Now we got to do an init command. Oops. And then oh, I messed it up again. Everything I'm trying to do, I'm getting it wrong. Hang with me. I promise I'll get this better. All right, and then we want to change it to blue. And there it goes, it's blue. And then it'll delay and go back. Okay, cool. So I think we're good there. So now we can unplug this. Turn off this. Plug it back in. No serial port. It should know that. And then flicker between red and blue. Optimistically, maybe. Guess not. All right. So what are we missing here then? Something is wrong with our logic, and I don't know what. Oh, maybe not. Hold on. That just flickered on red, right? Was I making that up? Did it just like flash? Like it's doing something? And I feel like I missed it. Weird. Maybe I'm seeing things. It wouldn't be the first time. All right, let's see here. The read from file. Oh, there it goes. It turned blue. Okay. So it is running. It just seems to be running really slow. So then it should light up red again, right? Yep, there it goes. Okay, so it's actually working perfectly. It's all except for the timing component. Whatever our timing was earlier, it's not following that. It's running much slower. Well, okay, hold on. That was faster there. I'm really confused right now. Like incredibly confused. I'm not sure the delay function is working exactly. Well, okay, now it seems maybe it's running in the way it should be. All right, let's try this. Let's run it. Uh, let's run it with the Python script, and then just see because that's a whole ton of behavior of constant changing things, and see what the result is from that. Oh, that was red, and then it just turned off. Red again. Ah, something is really weird. I swear the delay function is just like wildly out of control. Like something is going way wrong there. Delay milliseconds. I wonder if this function is specific to Arduino. Like by running it on Teensy or something else like that, because I remember having trouble with it on the other platform too. If I take out this Arduino library and try and compile it, I'm pretty sure that throws errors because the delay doesn't have a definition. Yep. So that doesn't work. A bunch of stuff is just not defined. Yeah, this is a tricky error. Because, like, you can see it's kind of working. Just not really as much as we need it to. All right, let's compile this again. Let's just run it, see if we can figure out like if it's a constant sort of delay or if there's something I'm missing. We'll never know. Oh, unused variable, unused, yeah, whatever. That's fine. Let's upload it. And then it should start up. But it might take a second to get everything. It seemed like the first time it just really went slow, and then after that it sped up. And I don't even know like what the cause of that is. Oh, the serial port was open. All right. All right, let's go here and try and run this. We might need to plug it in and just try and run it again immediately because I don't think it's going to work. Attempting to use a port that is not open. Oh, it really doesn't like that, does it? Hang on. Just making sure it's still available. Yep. This might be an issue. We might have to change things if I can't get it to just work out of the box with the Python script. There it goes. Now it's open. But it's not doing anything because it's already timed out. 2, 3, 4. It can never be that easy. Let's see. Zero baud rate. This is where the other board actually shined, is that you could open a serial port and that would reset it, which was ideal. All right. I wonder if, I don't know if we're going to finish this tonight with this bug, because this is a little weird and very hard to debug. So we need it to basically run without being plugged in, which is very hard to do. So. That's so odd. Is there anything wrong in my logic that caused this? Serial begin. While not serial. Maybe because it's not printing the ready response, this could be it. I could see there being a lot of issues with the initial commands because of this. Oh, maybe that is it. If it's like... Because I know it's probably waiting for a ready command and then trying to do other... Like, it's not doing anything because of all that debug stuff in there. Let me see if I can find in my... Here, I'll zoom in a little bit for you all to see better. But basically, anywhere where we read or write, basically read. Command, set port, set link, set color, begin. If result equals ready, wait. The logic on this seems wrong. It should be, it seems like it should be if does not equal ready. But then it would return false. It must be waiting for something. Oh, I don't know the debugging. I'll have enough time to boot into it. All right, well, there is a way to try and fix this. Not that one. Here we go. Our time to serial. We're going to up this to like 30,000. So that'll give us 30 seconds, basically. Plenty of time to try whatever we need to. Because we're really close. All right, let's go here. Debugger, nothing. Okay. It might be because something was already running. Let's try again. If result 0, 1, 2, 3, 4, 5, 6 ready. This is for the auto detect. It shouldn't be doing that though, right? Auto detect equals false. I thought we were specifying a port at the beginning. Does it not do that? Port. Lighting controller, port. If port is not none, set port. Set color, fast mode equals false. I'm definitely missing something here. Maybe is there a begin? Here it is. If auto detect. Else, okay. So this is not the auto detect. If result equals ready, return false. Check port. This seems wrong. I don't know why this has ever worked. If this is, it's like we are looking for this ready and we want it to be ready. This init function, it just doesn't seem to be, this begin function just doesn't seem to be working correctly. And then I think I really just got to go in here and get rid of all these debug statements as well, because they're messing up the beginning of this. Which is fine. We know that this part kind of works now. It's the delay function that's confusing everything. All right, verify that again. Make sure this isn't running. No, don't. Wrong button. All right. Then upload this. All right, and run this. Maybe that got farther. Okay. Trying again. All right, we got ready. So let's keep going. Port not open error. What am I doing wrong here? This is really odd. Just learning about the serial port stuff I have going on. If result does not equal ready. What? It equals exactly that. Oh, I wonder if we have to specify that. That might be a thing, actually. That might be the reason we never caught that error. All right, trying again. All right. Self. Received. What's the result equal to here? Okay, yeah, so our debug stuff is being received now. So it seems like it is kind of working, but we need to take out a lot of our debug stuff again. So let's get started. This and that. I think actually those are the two majors. Like, everything else I think is fine. Error compiling for board. That was weird. It must have still had something like in the process of saving. Alright. Results. Command received. Okay, it's working. Got that debugged. I know you wish you could help. It's just knowing that somebody is sticking with me, even though this is really boring, is a huge help. Okay, so now we're running through all this. There's the lasers. You'll see the underside lights come on. There they are. All right, I'm going to unplug it here. So now we reached the end of that, and now I'm going to plug it back in and see if it plays back. It should, because there's no port open. Oh, but we're going to have to wait like 30 seconds or something. All right, it's going to be a minute. Does anybody have anything interesting they want to talk about while we're waiting for this thing to boot back up? We should see everything turn off at some point and then boot back in. We probably could upload and change the length of that to test. Oh, there it goes. If we can figure out this timing thing... Oh, well, that's annoying. It didn't record anything. Ah, come on. If we could figure out this timing thing and get that working, then this project would be done. And it'd be time to move on to the next one. Wait. I think I've had some sort of thought that explains some of the confusion. First, though, I need to go back here. I think there's something No, I didn't change that. Dang it. It can't ever be easy. Open SD card. Yeah, I have put a lot. It's been like 2 months. All right, this is... I need to know what's on this SD card. That might explain some of the issues that I'm having. Because I don't know that whatever it recorded was what I thought it recorded. Oh, okay. That's interesting. So that's what it actually recorded when I was doing it. Really, really weird. But basically, light red, bright red, wait a really long time, blue. Okay, that explains the weird behavior then. Let me take some of this out so that we just get the thing that we wanted. Oh, I ran in it several times too. That was probably messing things up as well. All right, so all of this. So we've learned that our recording feature is not as great as we had hoped. And then just trying to make sure I get everything correctly. Here we go. delay. Okay, that should be the actual thing that we wanted, and we can try this out real quick. Let me eject this. And then we start again. And hopefully this makes more sense this time. Oh, we still gotta wait 30 seconds. I don't want to wait that again. Let's do 5,000 milliseconds, verify, and upload. Okay, let's try that. Okay, that's faster. Red, and then it shouldn't take too long, and flip to blue. I'm just wondering if it's still taking like too long though. There's the blue. That turns off, then it should go back to red again. Okay, that's optimistic start. Let's calculate our delays and see if they're correct. All right. Screenshot of that. Close this back out. No, not that one. This one. Okay. Now we can do a timing analysis and see. So we know the delay between red and blue, so those values added together. All right, let's go to our programmer calculator here. We're in hex. So in hex, 20C8 plus 1138 is equal to decimal 4,408, so 4.5 seconds. So 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. It's way longer than it should be. And then much shorter for, okay. Let me time this. So basically I want to see how long it takes between turning red and then, or turning blue and then, or turning red and then turning blue. Because that will give us a very clear idea of exactly how long this is taken. Oops, I messed up my timer already. Alright, wait for it to turn off and turn back red. It's possible it's off by a constant and we can just divide by that constant. Alright, when it turns blue. .8 seconds, so roughly 3 times the length it's supposed to be. And then how long is it blue for? Let's do 1209. Oh, wait. I might have done that math wrong then. Hold on. 20C8. Oops. 20C8 plus. Nope. Stop. Okay. 20C8 plus 1138 equals 12.8 seconds. Okay, so that's actually correct. It just took me that long to actually do it. Actually type in the commands. Okay. So our timing appears to be correct. No issues there. So that's good. Now we just have to figure out why everything's not getting recorded correctly. And that I don't know the answer to. But we'll try it again. Because we've basically taken out everything here. Is there a thing that actually sends the command here? There's got to be a function for that, right? Create command, enable fast mode, send slow command. Where's that called at? Show NeoPixel slow. All right, I'm just gonna print command because I just want to see this happen. All right, unplug this and then plug it in and start this up. Enter fast. It's literally the first thing it does. Oh, I bet our delay doesn't work with fast mode. That's what's going on here. At least on the playback side. All right, hold on. Let me disable that here. I know somewhere in here I'm actually telling it. Let's do false. That could explain some things. A lot of commands to do this basic stuff. It seems to be running at a pretty good speed though. Because the USB is so much faster now that it almost doesn't matter. It's a little slower, I think. Probably because I'm having to do all these print statements as well. But that's okay. Alright, then I'm going to kill this. Unplug it. And then theoretically, this SD card should have all of that data that just went through on it. Well, it's got something. It doesn't delete the previous stuff, though. These are really interesting, too. I've seen some stuff that I think is not working properly with my script. Some bugs that I've never caught before. All right. So let me take this. Device is currently in use. It's always in use. All right, and then I'll plug it in and run it back. And maybe it'll run. I probably got to come up with a delay command for fast mode. I didn't think about that. Should wait 12 seconds, see it turn blue. And then we should see the actual... Okay, here it goes. Okay, so it's working. It recorded it. It's playing it back. We're so close. I got to add a delay for fast mode. All right, let's see here. I'm not going to do this tonight. I'll do this next time because we're so close to being done. But this is awesome. It's actually just running from being plugged in. It's not even... My computer's not controlling it right now. So we've had at least a fair amount of success tonight. All right, fast mode. Exit, update. And then we need delay. So yeah, we'll have to add it in right here. That shouldn't be too hard to do, actually. We could just start with a T for time and then a number right after. That's the actual delay function. Or the actual number for the delay. Should be fairly easy to do. But it's running pretty good. So that's good news. All right, so we got to do that. And then we also have to erase the SD card when we start up. Well, excuse me. We might be able to do that now, actually. Or at least figure out how to. That shouldn't be that hard. All right, if we open... If we open and write right here, is there an erase? Let's see. Oh, okay, that's why there's only two. Okay. The two modes are read and write is actually append. And we'll open for reading as well. There's a remove class here. Remove a file from the SD card. sd.remove file name. That's what we want to do right here. sd.remove and then the file name. And what this will do is boot up the file or remove it and then create a new one whenever we boot into this mode, which is exactly what we want to do. I might just clean this up. We're pretty close right here. I might just clean this up this weekend because we just need to finish up real quick. Well, we'll see. We'll probably do this next time. I'm just trying to think ahead for scheduling. All right, let's upload this. Uploaded, and let's see if it works. So I'm gonna plug this in, start it up. And then when I take this SD card out, we should see all that junk at the beginning just deleted. So I'm going to let it run through its whole thing again, and then we'll go from there. Should be getting close. Okay, I think that's good. Oh, we should see the landing lights come up real quick. There they are. Okay. I'll unplug this. And then check it real quick. And it did. It deleted the stuff at the beginning and started over. Excellent. So that's good. So we just need to add that delay, fix that delay in fast mode, and then we're done. Like 100% done. All right, so that's what I'll be doing next time. It shouldn't take too long. We'll get that sorted out, and then we'll move into the next project, which I can't wait to talk about and just plan and work through. It should be a fun one. I'm trying to think if there's anything else here. I think we're good. Apologies for not being able to finish the project tonight. I tried everything I could, but there was a lot of bugs, and this part of it turned out to be a little more complicated than I was expecting. But we made really good progress, and it works pretty well, actually. So that's a good start. So I will see you all next time, and we will finish this up, fix those delays in fast mode, which I didn't even think about. And then we will start scoping out the next project and figuring out exactly how we want to do it. So, yeah. Thank you for sticking with me tonight. Thank you for watching, and have a good Thursday. Bye.